Hope the sound is there. Tell me if you are hearing from me, guys. Please let me know if you are hearing from me. Is there sound? Some are writing their comments, and before starting, I want to know if you are hearing me. Are you somehow getting me? Let me know with your comments. Yes, Niyonzima Alfonso. Are you getting me? Oh my gosh. What am I? What am I facing? Are you hearing the voice? Okay, thank you very much. Thank you very much. Now, the question is, when is any transformation said to be linear? As you see, here we are talking about linear transformation. When is that linear transformation said to be linear? When is any transformation said to be linear? A transformation to be linear, a transformation is linear if it satisfies or fulfills those two properties. Here we have two vectors u and v. U and V are the vectors of vector space V. Now, if taking the function of U plus V, when it is split to f of U plus f of V, that property 1 is verified. We say that that property is verified. When having this vector U or V, any one of your choice, and have the product of U, V into F, what gives you alpha times f of U. The property 2 is also verified. More generally, instead of using these two properties, you can combine them together and use this. You can combine them together and use this. For alpha and beta are real numbers, and U and V vectors in vector space V, f of alpha U plus beta V must be the same as alpha times f of U plus beta times f of V. When this is verified, you conclude saying that your transformation is linear, also rectangular. Hope you are getting me. Please share the live. Can you share the live, please? Can you? Now, let's now continue. I have had an example show that f of xy, which is x plus y, comma y, is linear. We need to show that an example that we have been given here is linear. To start, you start letting u. You start letting u. U must be x1, y1. That means v must be x2, y2 intuitively. Okay? Or you can assume other values or variables of your choice. Now, what you do after assuming these two vectors, you find their sum, the sum of those two vectors, where u plus v was given by x1 plus v1. It's done the same way as you did when summing two vectors. Hope that's great. Okay. So u plus v is given by x1 plus x2, comma y1 plus y2. That's it. When having f of u plus v, here this stands for x, while this stands for y. That's why instead of having this, you replace this x by x1 plus x2 and replace y by y1 plus y2. That's what we did here. I have taken x1 plus x2 plus y1 plus y2 to mean this, comma, here y. As I told you, y is going to be replaced by y1 plus y2. Now, that's it. This. When reaching here, we need to group stuffs with sub 1. Sub 1, those stuffs with x1 and y1. We group them together, and x2, y2 must be grouped together. This is what we saw. Well, here we saw we need to take x1 plus y1. Group this, x1 plus y1 plus x2 and y2, they go together, comma y1 plus y2. After this, we need to split this into two functions. Two functions of which one will be a function of x1, y1, another x2, y2. Here is how it was done. I've taken x1 plus y1, comma y1. That is one function. Plus x2 plus y2, comma y2, which is this. As you see, this function will be a function of x1 and y1. And x1 and y1 was u. That's why this must be a function of u. While this must be a function of v. Hope you are watching the point and it's clear. If any question, you can now ask. Use comment if you have any question before jumping to the second property. Before jumping to the second property, you can ask any question if you have. Do you have it? Yes, Virumvikana. Thank you, Teta Sandra. Let me continue with you. Let's now verify the property 2. The property was this. We need to take alpha as a real number and u as a vector. And what we need to do, we were assuming u to be x1, comma y1. So alpha u is going to be alpha x1, comma alpha y1. Then f of alpha u is going to be, as you see, we'll be replacing x. This will be replacing x, while all of this will be replacing y in the transformation. Now, this is going to be alpha x1 plus alpha y1, comma alpha y1. Because here is the product of alpha, we want to take alpha out of the brackets. This is going to be alpha into x1 plus y1, comma y1. As you saw, this is the function of u. Here is f of u, and this is alpha. As you see, this is proven. Since it's proven, we conclude conclusion. We conclude saying fxy, which is x plus y, comma y, is linear. This is the first way you can verify that. Let's look at the second alternative 2. Alternative 2, instead of using this property and this one, we need to use this. Let me show you how. And maybe the second method will be easy. Maybe it's gonna be easy for you guys. The other alternative, we need to use this property f of alpha u plus beta v. We need to show that this is alpha f of u plus beta f of v. Okay, remember our u is x1, y1, while vector v is x2, y2. What we need is to find alpha u. Here alpha u is going to be alpha x1, alpha y1. Beta v is going to be beta x2, comma, beta y2. So what is going to be done is to find the sum, this sum. It means we are going to have alpha u plus beta v. This is going to be alpha x1, alpha y1 plus beta x2, comma, beta y2. As you see, this is going to be alpha x1 plus beta x2. Here is alpha x1 plus beta x2, comma, alpha y1 plus beta y2. Now, f of alpha u plus beta v is going to be, this will be pressing x in the given transformation. It will be taking the value of x, while all of this will be taking the value of y in our transformation. This is going to be, instead of having x, we are going to have alpha x1 plus beta x2. Here is alpha x1 plus beta x2. Here is plus y. I told you that y is going to have the value, which is this. This is going to be alpha y1 plus beta y2. That is a comma y, and y has this value. Here is alpha y1 plus beta y2. Now, from the beginning, we said that we group starts with the same subnumber. We have x1, x2, y1, y2. The sub I mean is 1 and 2. Now, we are going to group. This will be grouped with this because they all have sub 1, sub 1. That means here we have alpha x1 plus alpha y1, comma, here we are going to have alpha y1 plus those with sub 2. Here we have beta x2 plus beta y2. This is going to be with this, comma, beta y2. Now, what is this? The first has alpha as a product. That's why I'm going to take out alpha to factorize alpha. This is going to be alpha into x1 plus y1, comma, y1 plus, here is beta, take beta out, this is going to be x2 plus y2, comma, y2. As you see here, this is a function of v because our v has the coordinates x2, y2. That's why this must be a function of v, while this is a function of u. This is going to be alpha f of u plus beta f of v. Because this is verified, the transformation fxy, which is x plus y, comma y, is linear. This is the conclusion we need to drop. Hope you are understanding. And any point is very good. Niyonzima teacher andika binini bigalagala. Thank you, Niyonzima. Ntabwo teacher, ntabwo bibona neza. Okay, teacher, kuko tutari kubona ibintu byanditse neza. I am going to check while you can see. Thanks, clear. Harimo ibihu teacher, ntabwo biri kugaragara. Maybe biraterwa n'aka gahanaguzo nagiye nkoresha. Next time I'll be changing that. Ariko ngiye kuri computer yanjye ndabona nsa nkaho ndi kubibona neza. Gusa reka tugerageze ubundi buryo. Noneho uko bigiye kugenda ngiye kwandika ikindi kibazo. Nimara kucyandika ndaza gutanga iminota mike kugira ngo buri wese afate agakayi ke agerageze. Nugerageza turebe ko tuza guhuza igisubizo. Let's now go. Can you have an example? That we are going to try. Or ntabwo byumvikanye, urugero rwa kabiri narwo narukora. Nta kibazo mumbwire. Niba urugero rwa kabiri narwo narubakorera, you can let me know. Stop using WhatsApp, but use comments instead. Example 2, guys. Okay, Manzi Keve ati rukore. Reka ngire vuba muraza gukora urugero rukurikiraho. Prove that the transformation f xy, which is, let me have x minus y, comma, 2x plus 5y. Are you getting that? Abantu bashaka kureba neza, bahindure screen quality kuri screen yabo kabisa. Yes, ushobora guhindura ukabona ukareba ku 1080 if you are using a PC. Niba uri gukoresha computer. Niyo nzima Alphonse ati rukore. Niyo mpamvu mutari kubona. Thank you Jeve Bizlema. Teta Sandra ati gute. Uragenda kuri ahantu handitse setting, urarebera kuri computer uri kurebaho, urebe ahantu handitse settings, hanyuma urahabona quality, uhindure quality. Nukandaho hariho 144p, 244p, there 360p, 480p, 720p, and 1080p, which is HD. Mudenga ati byakunze Lata Gervais, thank you very much. Okay, let's continue with this example 2. As I told you, we can use, okay, is linear here, as is linear or not. The transformation to be linear, as we said, must fulfill the properties below. The property 1, for u and v in vector space V, f of u plus v must be equal to f of u plus f of v. Hope you are getting that. For another the number alpha, the second property is that f of alpha u will be alpha into times f of u. Hope you remember these two properties. Okay, hope you remember these two properties. 1, as I told you, we assume u to be x1, comma y1, v to be x2, comma y2. What you need to find is, what is u plus v? U plus v, as you see, this is going to be x1, comma y1 plus x2, comma y2. This will be we need to take this x1 plus x2. Here is x1 plus x2, comma. We need to have y1 plus y2, y1 plus y2. The same way you add vectors. Okay. After this, because here is u plus v, we need f of u plus v. As you see, that must be f of u plus v is this. Here is x1 plus x2, comma, y1 plus y2. As you see, I told you that this replaces x in the given transformation. It replaces x in the given transformation. Means x will be replaced by x1 plus x2. And 1 will be replaced by y1 plus y2. This is what we are going to have. Here is, we are going to have, instead of having x, we'll be having x1 plus x2 minus, instead of writing 1, we have y1 plus y2, comma, because here is a comma, we have 2 times, instead of writing x, we have x1 plus x2. Here is x1 plus x2 plus 5 into y1 plus y2, because y is replaced by y1 plus y2. This will be, as I told you, we group stuffs with sub 1. We are going to group them. But before doing that, let's explain this. We have x1 plus x2 minus y1 minus y2, comma, you have 2x1 plus 2x2 plus 5y1 plus 5y2. This is what you have. Now we are going to group things with 1. Are you seeing that? That is, this is going to be x1 minus y1 plus x2 minus y2, comma, here is 2x1 plus 5y1 plus 2x2 plus 5y2. Here it's. Now, we are going to split this transformation into 2 linear transformation, where it will be expressed by the sum of the 2. Text starts with sub 1, comma starts with sub 1. This will be with this. That's why here we have x1 minus y1, comma, this 2x1 plus 5y1. Then add those with 2. 2 are sub. Here is x2 minus y2, comma, 2x2 plus 5y2. As you see, this will be a function of u, because our u is x1 and y1. That's why this must be a function of u, while this must be a function of v. Thus, f of u plus v is the sum of f of u plus f of v. Here, the first property is hard. Okay, barashimira chef. What about the second property? I am going to use this part, guys. Hope the first property was fully understood. Let's write the second property, the property 2. We need f of alpha u. To verify it's alpha times f of u. As u is x1, comma y1, alpha u is going to be alpha x1, comma alpha y1. We need to know f alpha u. This will be f of alpha x1, comma alpha y1. This alpha x1 will stand for x, while this will stand for y. In our transformation, which is this, x will be replaced by alpha x1 and y will be replaced by alpha y1. That's why this is going to be, instead of having x, we have alpha x1 minus alpha y1, comma, this alpha x1 will be replacing x. That's why here we have 2 times alpha x1 plus 5 times alpha y1. Here we have alpha everywhere. That's why we need to take it out. This is going to be alpha into x1 minus y1, comma, 2x1 plus 5y1. As you see, this guys is this. That is, this is going to be f of u. Thus, alpha f of alpha u is equal to this alpha times f of u. Because the two properties, the property 1 here and the property 2 here are verified, we conclude saying that the given transformation is linear. Conclusion: is linear. All you can use the property 2 that groups those two properties together. Okay. Can I have you one question as exercise? Let me do it for you. Exercise. Have your notebooks and pens ready so that the transformation f of xy which is 2x plus y comma x is linear or not? Is linear or can you do that? Please, please try. Try your best. Can you? Let me know in comment section that you can. Dorcas ati teacher ntacyo turi kumva. Ikihe Dorcas? Dorcas ni ikihe mutari kumva? Ariko ndabona hashize umwanya, birashoboka ko message wagitanze kare. Ni umugabo Kedi ati yes, he saying yes. Please Kedi, do it first, and the others do it first. I'll be waiting for your answer. That will be submitted on WhatsApp group. I'll be knowing that you have understood the question. Any other guys trying? Let me know that it's yes. Any other one is trying? I'm going to give you questions as assignment. I'm gonna give you questions as assignment, guys. Let me put them here. Assignment: show that the following transformations are linear or not. Here we have one. F is a linear mapping that maps L2 to L2 as xy is this x minus y comma y. That is the transformation one. B, F is a linear mapping that maps L2 to R2 as here is x comma x minus 2y. C, H is a linear mapping that maps L2 to R2 as xy maps to x square comma y. D, we have G as a mapping that maps L2 to L2 as here is xy, which maps to x plus y comma y square. The next question E is a mapping G that maps L2 to L2 as x comma y is x plus 2y, x plus 3y. Here are the question, guys. Note them quickly. We are going to continue with how to find an inverse transformation. Danny Twizel, Danny Ibrahim is now typing. I'm waiting to see what you want us to know. He's asking ariko mwambwiye iyi ni unit ya kangahe? Danny, this is unit 11 in senior first unit book. I hope you get that. Is this unity new for you? Is it new for you? Yes, teacher, thank you very much. And welcome. Have you tried the question? Have you tried the question, please? Mm, How many are you there? Who has tried the question? Anyone can answer me. Welcome, Danny Ibrahim. Welcome. Can you try it? I can't. Peter Sandra is saying yes, you can. Numugabo Kedi teacher ntacyo mbonye ko aroineya. But the question I gave you, the first one, that is linear. This one is linear. 2x plus y comma x. That is linear. The first question here is linear. The second one is linear. The third one is nonlinear. The fourth one is nonlinear. But the fifth is linear because this is similar to the question you have been dealing with here. They are looking the same. Manzi Keve, thank you very much. You are still dealing with the question. Turacyari gukora. That is good. That's what I want from you to do. Let me wait for you. Make sure you have kept these questions somewhere so that next time we'll be trying them. Those who were asking me to send them the question in the morning, please, please keep that in mind that the questions I give you here in life must be kept somewhere to avoid you going back to the life. If you finish doing the question, please send your answer to WhatsApp. I'll be checking the answer you'll be giving me. Dani ati njyewe biransaba kuza gusubiramo. Dani humura, humura ntugire ikibazo. Ariko reka nongere mbasabe abari hano, iyi live mushobora kuyisangiza inshuti zanyu. Hari abataje muri class, you can share them this live. None is done with the question? None of you is done? Thank you for your subscription, guys. Please, Danny, keep being with us. Komeza ugume hamwe natwe kuko ibyo tugiye kugeraho most of times nibyo bikunda kubazwa cyane. Biraza ari kimwe n'ibibazo nigeze mbaha kandi by now nibyo tugiye gukurikizaho. We are going to talk about inverse transformation. Remember the question I gave you in test, which you have done before you go in vacancy, in holidays. The question is near four questions. Mishu ati thank you yabibutsaga ko aha naho teacher wanyu yabandikiye avuga ko mugomba gukora holiday package muri English. Okay. There are 5 students in life. Are you still working? We are going to talk about the inverse of linear transformation. But before continuing, I want to check your WhatsApp group. There is no one submit. None of you submitted his or her grades. None of you. Are they still working? There is no answer. Dear friends, please come back in the mode to continue the lesson. Okay, the way we find an inverse of a linear transformation. If the transformation is a map that maps, is a mapping that maps L2 to L2, if T all if maps L2 to L2, i.e., i.e., we can have f of xy as a1x plus b1y, or let me have a11x plus a12y, comma, a21x plus a22y. Assume that the inverse transformation is f of u and v. F of u and v. This is how we deal with this. Guys, you equate this to v. What we do, a11x plus a12y is equal to u. And a21x plus a22y is equal to v. The next is to swap xy to uv. Means x is going to be replaced by u and y by v. That's how to swap. This means when swapping x and u, we are going to have a11x, sorry, a11u plus a12y, and this is going to be x and is swapped to u. Here u will be replaced by x. Again, here is a12, sorry, a21, u plus a22, here is v, guys, not, here is v, and this is going to be y. What is done here, solve for u and v. And you will be hitting the way to find an inverse of linear transformation. That is the best way to find a linear transformation. Here is the first alternative. Here is the first alternative. The second alternative is that we like this transformation in matrix form. This is how to do it. I'm going to show you guys how to do that question. Okay, we assume fxy is written like, here is going to be a matrix. Here is going to be a matrix, guys. And this matrix will be multiplied by xy, because here we have x and y. This matrix is formed by taking the coefficients. This must be low 1, while this must be low 2. This is going to be a11, and here is a12, This is going to be A12, and this is A22. Assume this is a matrix A. You know how to find the inverse of a 2 by 2 matrix. Now, the inverse of linear transformation xy will be given by the inverse of this matrix A times xy. What we do is to find the inverse of this matrix, guys. Can you allow me to do one simple question to show you how to do that? If you can, I thank you. Example, consider the transformation fxy, which is f plus y, comma, x plus y, comma, x minus y. Find the inverse transformation. Find the inverse transformation. Here is the question. Are you there? Hope you were back to the live. Okay. The first method we're talking about is to equate this u and this v. Here we have x plus y. This is u, while x minus y, this is v. We said that we swap x and y. Here we had f of xy, and the inverse must be f of u v. Now, as I told you, we need to swap x and y. Swap xy uv. X is going to be replaced by u, and u replaced by x. And y is going to be replaced by v, and v by y. This is how to do that. Here, replace u, x by u. Here we have u plus and y is replaced by v plus v. And this is gonna be because x was replaced by u and u replaced by x. That's why here must be x. Here we have u minus v. This is gonna be w. V is replaced by y and y replaced by x. That's why here is gonna be y. So we are going to eliminate using elimination method. Because here v here is positive, y that one here is negative. These v are going to cancel one another. That's why here we are going to sum u and u to be 2u. And this is going to be the sum of x and y. Here is x plus y. You see, guys, u is going to be x plus y over 2. And this is 1 over 2 times x plus 1 over 2 times y. This is you guys. To find the v, let me copy this. U plus v, which is x, u minus v, which is y. Let me eliminate u by multiplying the second equation by minus. This is going to be u plus v, which is x, minus u plus v, which is minus y. So, summing the two equations, this stuff will be canceling this. Here is going to be 2v, which is x minus y. So, v is going to be a half of x minus y. This is 1 over 2 times x minus 1 over 2 times y. Guys, the inverse function will be f of u is this. Here u is this. We have 1 over 2x plus 1 over 2y, comma v is going to be 1 over 2x minus 1 over 2y. This is the inverse transformation of the given function. Okay. Do you think this way is easier than using that of the determinant? Do you think so? Now, let's try the second alternative. Hope you are getting something from the tutorial. Second alternative, guys. I told you that this f of x, y can be written in matrix form, where we have x and y here. What is going to be done here? We are going to only consider the coefficients of x and that of y. These coefficients will be on low 1, while these coefficients will be on low 2. This is going to be 1, 1, while here is 1 minus 1. We assume this to be a matrix A. Here, a matrix A is going to be 1, 1, 1 minus 1. You know, when finding a 2 by 2 inverse matrix, the inverse of matrix is going to be a reciprocal of the determinant matrix, the determinant of matrix A times, here we switch switch diagonals to be -1 and 1. The second diagonals are multiplied by -1. That's why here we are going to multiply -1, even here -1. The problem is now, what is the determinant of the matrix A? Here, the determinant is going to be, we take this times this, we have 1 times -1 minus this times this, 1 times 1. This is going to be -1 minus 1. And the determinant of A is going to be -2. So the inverse is going to be 1 by -2 times this matrix. Here is -1, here -1, here -1, and here 1. This is going to be, we are going to multiply this -1/2 inside here. This will be 1/2, here 1/2, here 1/2, and here -1/2. So the inverse transformation is going to be, we need 1/2, 1/2, 1/2 minus 1/2 times xy. Do you remember how we multiply two matrices or matrix by vector? Remember that we take row dot column. That's one, we'll be having row 1 dot column 1. This is going to be, this half we multiply this x to be 1/2 times x plus this 1/2 multiplies 1 y, sorry, to be a half of y, comma, this multiplies x, we have a half of x, this multiplies this, we have minus a half of y, guys. As you see, this answer is the same as this. That answer is the answers are the same. And here are two different ways of getting the inverse of a linear transformation. Do you see it's challenging or somehow understandable? Challenging or understandable? Challenging or understandable? Let me have one more, another one example, another example. One more example. Find the inverse transformation of let me have the question y x minus y x plus 2 x plus 2y. Okay, we can use this way or use that. We'll be choosing which one is simple for you.